or the data drive is available for use. You can also see this from the DiskPart prompt by typing list volume, which again shows you that the data volume has been created and assigned the drive letter of E. Here you also see that the NTFS file system is being used and the status of the disk is healthy. Let's partition our last drive, but this time let's use the GPT partition style. Currently, the only disk that has unallocated space on it is disk 2, so I'll type select disk 2. And as we did before to specify a partition style, I'll use the convert command, but I'll specify GPT this time. For this disk, I want to have more than one volume, so instead of using the entire disk, let's specify a size. To do that, I'll type create partition primary. Then, to specify the size, I use the size equals 63,000 option and press enter. Now the 63,000 is in megabytes, which means that our volume will be about 63 gigabytes in size. To see the drive's current state, I type list partition. Notice that when I do, though, there are 2 partitions instead of just 1. That's because when we specified that we wanted to use GPT, it automatically created its own small EFI system partition. So the 63 gigabyte primary partition we just created is partition 2 this time. Since there are now 2 partitions on this disk, I need to tell DiskPart which one I want to use. I'll type select partition 2. Like we did before, we used the format command to prepare the disk. As you can see from this command, we specified that we wanted to use NTFS, and the label for this disk will be Finance. Next, to assign a drive letter to this new partition, I'll type assign letter F, the next available letter, and press enter. Now when I type list volume, you see that the Finance volume was successfully created. When I open Disk Management, you not only see that the Finance volume was created, but also that I still have about 65 gigabytes of unallocated space I can use to create 1 or more volumes. Since this disk was initialized using GPT, to create the next partition in this unallocated space, I'd use the same command from earlier, create partition primary. And then we'd format the drive and assign a drive letter as we did before. We won't take the time to do that now, so to close DiskPart, I just type exit. That's it for this demonstration. In this demo, we showed you how to use the DiskPart command to create partitions and file systems on a Windows system. We first used DiskPart to create and format an MBR disk. We ended by using DiskPart to create and format a GPT disk.
So everyone, you can see how to do that one in the command prompt. So command prompt, little bit risky. If you know or if you're familiar with the command prompt, you can use that one. Because in the GUI system, you can control lots of things, like as they will give you one interface and you can change something in there. But in the command prompt, if you write down anything, that one will be affecting your hard disk directly. That means that command's very, you can say that is a very risky command, okay? But most of the people working in the command line interfaces, so if you want, you can use that way. And another thing, you can see this hard disk partition into 2 ways. One is MBR, another one is GPT. So normally we are using GPT because of our new computers are use the UEFI model. That means instead of BIOS, we are using that one. So for new technology, we are using GPT. And those who are old computer, like think about 5 years ago computer or 10 years ago computer you want to use right now. So for that computer, we are used in here MBR format. That's just change the date and time, and it's automatically update. Need to use the update version of your any types of software or hardware devices. Okay, let's go to the next step. Let's see any other thing is available. Yes, there is another one, convert volumes.
In this demonstration, we're going to learn how to work with storage volumes and convert them from FAT32 to NTFS on Windows. The primary tool for managing volumes and disks on Windows is the Disk Management tool. I've opened it up, and we can see the current configuration of these devices. We see that the system has 3 hard disks installed, labeled as disks 0, 1, and 2. Disk 0 has 3 partitions defined. One is for EFI booting, one is the C drive, and the last is the recovery partition. Notice that with disk 1 and 2, while they do have primary partitions defined on them that encompass the entire devices, there's no file system. They're online, meaning that the operating system is aware of them and that they're accessible, but they're labeled as unallocated. They have no drive letter assigned to them. If I navigate to File Explorer, this PC, I only see the C drive. For us to use disks 1 and 2, we have to prepare them first. The simplest way is to right-click a target device in Disk Management and then select New Simple Volume. This starts the New Simple Volume wizard, which walks you through the process of creating a new volume, including formatting and labeling it. I'll select Next and then leave the available space as the selected size and click Next. I'll change the assigned drive letter to F and click Next. I'm then prompted to decide whether to format the volume or not, which I need to do to use it. I'll leave the file system as the default setting, leave the allocation unit size as the default as well, and change the volume label to storage. I'll leave the quick format option selected and not include any compression, and then select Next. I then see a summary screen with all these selected items. Since it has things configured the way I want them, I'll click Finish for the process to be completed. Now, opening Windows Explorer, I see that I have an F drive listed under this PC. We've successfully prepared this device with Disk Management. Sometimes, though, you won't have the Disk Management tool available. You may not even have a graphical user interface. This usually only happens with Windows Server systems, so in situations like this, it's possible to prepare a disk for use with a tool named DiskPart. To see how this works, let's open a command prompt as an administrator. Despite the name, DiskPart does more than partition storage devices. The DiskPart tool allows you to change partition types and create, modify, or delete partitions, as well as assign drive letters and format volumes with file systems. As a command line tool, these functions happen inside of its own command prompt. Let's start with the list disk command. This prints out a list of all storage devices currently connected to the system. As you can see, we have 3 listed, just like what we saw with the Disk Management tool. We'll work with disk 2. From the prompt, I'll select disk 2. Next, I'll create the partition using the create partition primary command. I'll then assign the drive letter using assigned letter equals G. Lastly, let's format the partition with a file system. We'll use FAT32. The command to do that is format fs equals FAT32, label equals backup, quick. The file system is created, and Windows notifies me that the G drive is now available. Let's verify that by looking in Windows Explorer. Sure enough, G is now displayed. Another important tool for working with FAT32 file systems is the convert command. Although we could easily run a format command or use DiskPart to format an existing FAT32 volume as NTFS, if there's already data on the device, that data would be lost. The convert command allows you to change the file system on a volume while allowing the data to remain intact. Let's start by typing convert /? to get a look at the options we have available to us. There's an example of the syntax at the top. We want to change the G drive to NTFS from FAT32. I'll use the following command, convert G:/fs:/NTFS. Now I'm prompted to enter the volume label. Then the process will be complete. To verify that the conversion has happened, I'll open File Explorer, this PC, and right-click on the G drive and select Properties. And as you can see, the file system is listed as NTFS. That's it for this demonstration. In this demo, we talked about formatting and converting volumes. We first learned how to use the Disk Management utility to work with disks and partitions. Next, we explored the DiskPart command to define and format volumes from the command line. Then we learned how to use the convert command to convert a FAT32 volume to an NTFS volume.
Let's say that I have a single hard disk that is formatted as my C drive. Over time, I've saved files and installed applications, and now the hard drive is full. I've run out of storage space on my computer. Of course, one solution is to install a new hard drive, format it, and assign it as the D drive. And this would work, except now I need to remember which files are on my C drive and which files are on my D drive, and if I've been shifting files back and forth, I might not remember where all the files are located. But what if my C drive was full? That would mean that my system drive was full, so there would be no space to install updates for Windows. And in addition to that, some of my applications require that they run on the system partition. In this case, adding an extra hard drive doesn't help me because if I install those applications on the new hard drive, they won't run without the system files. They have to be in the same partition as the system drive, but the system drive is full. In this video, we'll learn how to add space to an existing volume when it becomes full. One solution to our problem is to use a mount point. With a mount point, I install a new hard drive. Then, using the free space on that hard drive, I create and format a partition, but I don't assign a drive letter to it. On my system drive, I create a new empty folder on the file system, and then I map or mount a volume to this empty folder. Now, all of the space that's on this new hard disk appears as if it's part of this volume. So now when I access the files on this drive, all I have to do is browse the file system on my original drive to the folder I created as a mount point. When I open the folder, I have access to the files that exist on this hard drive. In order to use a mount point, there are some rules that you should follow. First, this folder needs to be empty. Second, this partition must be formatted with NTFS. Mount points work on either a basic or a dynamic disk. In fact, one of the strengths of using a mount point is that we do not need to upgrade the basic disk to dynamic disk to create a mount point. Another solution for adding space to an existing volume is to extend the volume. Let's look at different ways to extend volumes. In this example, instead of using a circle to represent my hard disk, we'll use a linear line to represent the hard disk. Then we'll add the existing partitions. Here I have the C drive, along with some free space, and I have a D drive assigned, along with more additional space. Let's squeeze another one in there on the end. We'll have an E drive with some more free space. And all of these partitions exist on the same physical disk. When you extend a volume, you simply take some free space and add that to an existing volume. So for instance, for my D volume, I could extend that to occupy the additional free space that was next to it, and now I have a larger volume than I originally started with. When extending volumes this way, you need to be aware of where the location of the free space is in relation to the drive that I want to expand. Contiguous space is free space that is directly next to an existing volume. So this free space here is contiguous to my C volume. This free space here is contiguous or next to the E volume. Also, if this disk is a basic disk, I can only extend other partitions to contiguous space. For example, I can take my E drive and extend it to the space that is here, but I cannot extend my D drive to the free space on the end. Non-contiguous space is free space that is not directly next to the volume that I want to expand. So this free space here is not contiguous to the E drive because it is not next to that drive. And similarly, this free space here is not contiguous to the C drive. However, if I were to upgrade this basic disk to a dynamic disk, I could now extend volumes to non-contiguous space on the same disk. For instance, my D drive could use the space on the end of the disk. But the rule about the system partition remains. Even on a dynamic disk, my C drive cannot be extended to any free space that is not contiguous. One of the rules when extending an existing volume is that the system drive can only be extended to free space that is contiguous to that drive. So in this case, I can extend my C drive to the free space here, but I cannot extend it to the free space on the end of the disk. In addition to using free space on the same disk, I can add a second disk and create partitions and free space on that disk. I can also take an existing volume on one disk and extend it to free space on a different disk. Using the contiguous and non-contiguous rules, you can determine how to extend your volumes to the second disk. If this were a basic disk, I can only extend my volume to contiguous free space. Extending onto a separate disk is not allowed when the disk is a basic disk. However, if I have a dynamic disk, then I can extend my volume to free space on a separate disk. This configuration is known as a spanned volume. It contains space from two different physical hard drives. A system volume can only be extended to contiguous free space regardless of whether it is a basic or a dynamic disk. so this system volume cannot be extended to a second disk. When you extend a volume onto another disk, you are only adding space to that disk. You are not adding other benefits like fault tolerance or an increase in speed. Let's review the rules for extending volumes. The first you need to know is whether your hard disk is a basic disk or a dynamic disk. On a basic disk, you can extend all volumes to contiguous free space, and this includes the system volume. If you have a dynamic disk, you can extend and span all volumes using non-contiguous free space. However, the system volume can only be extended to contiguous free space. It cannot span volumes. One final rule for extending and spanning is that the volumes must be formatted with NTFS. If you're using any other file system, you'll need to convert your volumes to NTFS before you can extend them. So to add space to an existing volume, you can use either a volume mount point or you can extend the volume. Both solutions require that the existing volume use the NTFS file system. Mount points can be used for volumes on either basic or dynamic disks. You can extend volumes on basic disks to contiguous free space on the same disk, or you can use dynamic disks to add free space on a different disk, and remember that the system volume has special restrictions.
Okay, give me 1 second, I'll share my screen again. Let's do one lab. Let's do create read arrays. Okay, can you see my screen?
Yes, sir, we can see.
You. Okay, this is our computer. We can see. Sorry. Okay, this is our computer, and no signal is there. So, and there is no shelf. That means maybe we need to do some another things. So let's see what is our task. You work at a computer repair store. You are building a new computer that will be used for video editing and picture storage. You have finished the operating system on disk 0. You have installed an operating system on disk 0. Then install the SATA hard drives. Now you want to add the following additional volumes. Okay, the editing volume, drive letter E, which will be used to store raw video files for editing. This volume needs to be optimized for performance. The media, that means we need to make two drive. One is this one, another one is this one. So what we need to do in this lab, your task, initialize all new disks using the GPT partition style. So first we need to initialize that one. So for that one, let's turn on our computer first. Because everything already set up, we don't need to use any hard drive. We need to use the software. You can see, so hardware part is used for the CompTIA part A, software part used for the CompTIA part 2. So you add hard disks, but without software part, like you need to go to the operating system, after that you need to format it. Without that one, you cannot do the it in the CompTIA part 1. So that part actually CompTIA part 2. But when you install any hard disks, you need to make a drive. So for this reason, we need to use the CompTIA part 2 in here also. This is the part for CompTIA part 2. Actually, that one is for the next course. Okay. Okay, let's do something. So we already know where is our hard disk. Hard disks always be available. Go to there and computer management or disk management. Maybe disk management, not computer management. You need to write down disk management. Press enter. When I press enter, then I can see disks 1, 2, 3, 4. 4 disks is available in here. They said initialize all new disks using GPT partition. So we need to choose from in here GPT partitions. There are two types of normally we are using. This one is older one. This is the new one. Okay. Now it's automated selected. So press OK button. Now first one is done. And you can see we have 4 disks, but there is only one drive. That one drive is C drive. That drive basically used for the operating system. This one. Sorry, this one C drive. And this one is system reserve. So we cannot use or we cannot see that things. And the rest of this 1, this 2, and this 3, this 4. That means 5 disks is available in my computer. So now let's come back in the second question. Create the editing volume E. That means we need to create volume or drive. That name will be editing, level is editing, and volume is your drive letter will be E. As a start volume, rate 0 using all of the space of disk 1 and disk 2. So we need to use these two things for our start volume. Okay, I'll share one recording on video about the rate. So right click on the first one, this one. In here you can see stripped volume. Click in there. Then there is some definition of why we need to use that one. So that one is basically used for the storage some data for faster work. So now press next. We can see by default first one is coming because of I right click in the first disk. They said in the instruction said use space disk 1 and disk 2. I need to use the disk 2. So select disk 2 and add. Then both disks are available in here. Now press next. They said assign E. So I by default that one D. So we need to assign E. Next. They did not say to me that NTFS, but by default we need to do the NTFS. But they said one thing, use editing. So that is the our volume name, editing. So now press next and press finish. So there is some message. Do you want to do that one? This message means are you doing correctly or not? Is there anything wrong or not? If anything wrong, then press no. If everything good, now press yes. I press yes. Now you can see these two drive will be created, only one drive. Now you can see that one is created, E drive. Now they said create media volume M as a mirror. Okay, now mirroring purpose, we need to create that one. So mirror means when you use this one, that one also be mirroring. Let's use right click, go to the new mirrored volume, press next. So by default, disk number 3 is available because I select in right click in there and I need to add another disk. They already said disk 3 and disk 4. Okay, in here the instruction is said format all of new volume using NTFS. So make sure everything you need to use the NTFS. So I select 2 disks. Now next, they assigned that one is M. So let's assign M. Next. Now they said NTFS. I select NTFS. Now I need to use the media. So copy it and paste in here media. Now press next. Finish. Yes, I need to do. Now these two drive will be mirror drive. So both are you can see M and both are you can see E. So this is our work actually. We finished our this lab. So when you finish your lab, if you have any confusion, you can check it again. If you have no more confusion, then you can click into the score lab. Check your what is your score. Check it. I can see my score is 100% correct. Everything. That means I'm happy. If you have any problem, anything you missed, so you can do another time, another attempt. Unlimited attempt will be available in here. At least you need to practice that one. So this is the lab. I have to save all the things because it shows the 100% I did it. So where is that file? Okay, in here I have to save that lab. So that one is 5.4.5. 5.4.5. Let's save it. Done for this lab. So we did it this lab. Okay, there is one RAID configuration, how to do that one. Okay, let's watch this video, and after this video, rest of time you can do your work. Okay, and to share my screen again, give me 1 second. Can you hear? Sound is available?
Yes, yes.
Thank you.
In this demonstration, we're going to show you how to create a software RAID array on Windows. There are two basic kinds that you can create, a hardware array or a software array. Let's first talk about hardware arrays. To create one, you'll either use a RAID expansion board plugged into the motherboard, or you'll use a RAID controller that's been integrated on the motherboard. Both options work well and provide great performance, but they also cost a little more than software arrays. If you don't want to spend the money, use the software RAID array that's defined within Windows. That's what we're going to do here. Again, just keep in mind that software RAID arrays don't perform as well as their hardware counterparts. To start making one, I right-click Start and then select Disk Management. 4 additional disks were recently added to this computer, so when Disk Management first opens, it asks me if I want to initialize them. If we don't initialize the disks, Disk Manager won't be able to access them, so I need to click OK to make sure that they're initialized. Now let's expand the window and adjust the pane so you can see all the disks. Notice that Disk 0 is the drive that our Windows operating system was installed on, but disks 1 through 4 are listed as being unallocated. This means that no partitions have been created and they don't contain any data yet. Also notice that disks 1 through 4 are currently defined as basic disks. That's not going to work. If we want to create a software RAID array with disk management, we have to use dynamic disks. So let's go ahead and convert these from basic to dynamic. To do that, I right-click on Disk 1 and select Convert to Dynamic Disk. When I do, I'm given the option to convert either just Disk 1 or all the disks in the system. Let's go ahead and select all the unallocated disks and click OK. We now see that disks 1 through 4 have been changed from basic to dynamic. With that change made, we're ready to start creating our RAID arrays. Let's start by right-clicking Disk 1. When I do, I see that I can create either a spanned, a striped, or a mirrored volume. Of these options, only striping and mirroring are RAID implementations. Note that a mirrored volume is equivalent to RAID 1 and a striped volume is equivalent to RAID 0. There's also an option to create a RAID 5 array, but that's grayed out because you can only use that option on server versions of Windows. The reason a span volume isn't really a RAID array is because all it does is span its data across multiple hard disks. This means that there's really no redundancy and no performance improvement. When you use this option, you're just increasing the storage size. I want to first create a mirrored volume. A mirrored volume uses 2 hard disks and writes data to both of them at the same time, basically any time an operation occurs. So if one of those disks goes down, a redundant copy of the data is available on the other disk. To create this volume type, I select New Mirrored Volume and click Next to begin. Since I started by right-clicking on Disk 1, that one is automatically added to the selected column. To add the second disk to the array, I select Disk 2 and click Add. Notice that each of these disks is about 1 terabyte in size. The total volume size is only going to be about 1 terabyte after we're done as well. This might be confusing at first because you may be thinking, I'm using 2 disks and each one is about 1 terabyte, so shouldn't the total size of the volume be 2 terabytes? The answer is no, at least not with mirrored array. Remember that with mirroring, we're writing data redundantly on both disks at the same time, so the total volume size is equal to just the size of one of the disks in the array, which is still 1 terabyte. Click Next to continue. Since drive letters C and D have already been used on this system, I'll assign a drive letter of E and click Next. I also want to format this new volume using the NTFS file system, so I'll keep that default option, but I'll change the volume name to Mirrored. After the volume has been created, I want to format it so that I can use it. To speed this up, I select Perform a Quick Format, click Next, and then Finish. Now we have to wait while the new mirrored volume is formatted. All right, it's ready. When I open File Explorer and select this PC, we see that our new E drive, which we called Mirrored, is showing up like it should. Let's close File Explorer and create a striped volume. Before we do, it's important to understand that with striping, the data we create is broken up into chunks, and those chunks are written to both disks in the volume at the same time. So we're not creating redundant data like we did with mirroring. Instead, we're spreading that data equally across the two disks. The advantage to this is increased performance because we're writing with two different controllers at the same time. In other words, disk reads and writes take considerably less time than they do with a standard volume. On the other hand, the danger is that if one of our striped disks goes down, all the data on the volume will be lost, as half of the information will have been written to the failed disk. Just remember that this is the main downside to this approach. Okay, now to create a striped volume, I begin by right-clicking on disk 3, selecting New Striped Volume, and clicking Next. Like before, the disk I started on, disk 3, is automatically added to the selected column. So now all I need to do is select disk 4 and click Add. But notice that when we look at the volume size, it's now equal to the sum of the two disks, disk 3 and disk 4. With striped volumes, the total volume size is the size of both disks. To continue, I click Next and leave F as the assigned drive letter. After clicking Next, we again have the option to choose our file system, which I'll leave as NTFS, and I'll change the volume name to Striped. I'll select the option to Perform a Quick Format again, click Next, and then Finish to end the process. All right, our striped volume has been created and formatted. When File Explorer is open and I select this PC, you see that we have the mirrored volume we created earlier and now also the striped volume. And that's all for this demonstration. In this demo, we talked about how to create software RAID arrays on Windows. We also went over the process for creating both mirrored and striped volumes.
Ahmad, you want to say something?
No, sir.
No, Asmat is raise her hand. Okay, give me 1 minute time to share one more video. That one is in daily life we are using Shrink. How to use that one? I already show you that one, but you can watch that video from. So give me 1 second.
In this demonstration, we're going to spend some time looking at how to shrink a volume on Windows. To do this, we need to use Disk Management. So I'll right-click on the Start icon and select Disk Management. Now let's maximize the program so we can see things better. Notice that we have 2 disks on the system and that there's no unallocated space available on either of them. On this system, I'm storing some sensitive data, and I want to be able to isolate that information so I can more easily restrict access to it. An easy way to do this is to create a separate volume and implement those permissions at the volume level. But I don't have that option because there's no disk space free. Then one option I do have, though, is to shrink the size of one of these volumes, which will then give me the room I need to create a new one. The data volume is about 808 gigabytes in size, and it encompasses all of disk 1. Since this drive is so large, it's a good one to shrink. To do so, I right-click on the volume and then select Shrink Volume. When I do, Disk Management automatically decides the maximum amount the disk can shrink. Notice that because the data volume isn't storing a lot of information, the shrink process can be fairly aggressive. Here's the volume's size before shrinking. As we saw before, it's about 808 gigabytes. And here's the size of the available shrink space, or in other words, the amount of space we can free up. As you see, it's about 803 gigabytes. This means that if we were to select the default shown, the data volume would end up being about 5 gigabytes in size. Since I know that I'll be adding a lot more data to this volume, that'll be smaller than I want. So instead, let's shrink it to about half the size. To do that, I tell Disk Management that I only want to free up about 412 gigabytes by entering 422419 megabytes here. This is how much space will be unallocated after the shrink. In the bottom field, you can see the size that the data volume will be after the split. Okay, let's click Shrink. Now the volume has been shrunk. The data volume is roughly 395 gigabytes in size at this point, and we now have about 412 gigabytes of unallocated space available. Let's go ahead and create a new simple volume in the unallocated space. To do that, I right-click on the unallocated space, select New Simple Volume, and then click Next. I want to use all the available space, so I'll just click Next again. By default, the next available drive letter of F is selected, which is fine. Click Next. When I format the volume, I want to use most of the defaults, which include using the NTFS file system and performing a quick format. I do, however, want to change the volume label to Secure to better represent the type of data that'll be stored there. So now I click Next and then Finish. Okay, great. Our new volume has been created and is now ready for use. We can verify this by opening File Explorer and selecting this PC. Here you can see the new secure F drive. Well, that's it for this demonstration. In this demo, we shrank and split a volume on Windows.
So everyone, rest of time you can do your practice lab 1 and submit it by today 6:30 p.m. If you have any question, concern about anything, please let me know through the email, or you can send me text in the WhatsApp. Because the class is online in my computer, so if you write down something in here, I cannot get